Today I'm going to go over the homework number 2, which is on lipids, and a little tiny question on enzymes as well. This homework is out of 17 in total, so when you fill out your homework assessment log, just put it out of 17 and then calculate your percentage from there. Okay, so question number 1. 7A, sorry. Describe the difference between the structure of a triglyceride molecule and the structure of a phospholipid molecule. Okay, so this question is actually worth 1 mark, and it's describing that difference in structure between a triglyceride and the phospholipid. Well, the big difference is that one of the fatty acid tails is replaced by a phosphate group. Now, remember, there are still going to be 2 fatty acid tails remaining in that molecule, and it's just one of them is replaced with a phosphate group. Now, with the mark scheme, just beware, you can refer to it as PO4 or PO43-, but they do change whether they accept this PO43- or PO4, so I would probably just say phosphate group. Don't get too confident and get it wrong. They will reject phosphorus, so just beware, it's phosphate, which is an ionic group, not phosphorus, which is an element. Okay, so part B. Describe how you would test for the presence of a lipid in a sample of food, and this question is worth 2 marks. So just beware with this question. You can refer to the actual process that you carry out, but look at the number of marks here. It's only worth 2 marks. So it doesn't want you to sort of go to town with it. There is another question that comes up later on in this series of homework where it's actually a 3-mark question, and it's the same question but worth 3 marks, and there is a little bit more it wants you to add. But this one, all it wants you to say is you add ethanol and then an equal volume of water. Now, when you've added the water, you want to shake the solution, and if you get this white emulsion, now that's a really key thing. You've got to say white emulsion, and then you've got to say then that links in with the solution contains lipids. So just beware, it's add ethanol, then add water, then shake. If you've got that white emulsion, then you have got lipids present. Now, they will not accept any other alcohol, so ethanol. So it's ethanol, not ethanol or ethanol. So you've got to beware with the spelling of that, because you'll get no marks for that. They'll accept alcohol if you say general alcohol. The second point about the white emulsion, if you say it's milky, you will also get that mark. So if you say the solution goes milky, they'll accept that. However, they do not accept cloudy. So get yourselves trained up. It's a white emulsion. And part C, it's only worth 1 mark. So describe how a saturated fatty acid is different from an unsaturated fatty acid. So the difference is obviously the saturated fatty acid has single carbon-to-carbon bonds. Now, get yourselves into the practice where you've got to say between carbons in the fatty acid tail, because obviously we know that a triglyceride is composed of the glycerol backbone and then the fatty acid tails. Now, obviously, we have carbon-to-carbon bonds in the glycerol as well, so just be specific when you say that. You've got to say between carbons in the fatty acid tail. The unsaturated fatty acids do have double bonds between the carbons in the fatty acid tail. Now, it's only worth 1 mark, so just keep it short. You can say one or the others, but I'll actually put both there. But yeah, so you need to say it's the bonds. Now, you can say it has at least 1 double bond between the carbons in the fatty acid tail, or you can say there are no double bonds, as well as on the flip side. So the next question is looking at a structure of a fat substitute, and you can see it looks like a little bit like a triglyceride. You've got your fatty acid sort of tails coming off here, but then you've got this molecule here called propylene glycol, which obviously isn't it's an extra addition there, and then you've got this bit here which sort of looks a bit like glycerol there. Now, the question says the fat substitute cannot be digested in the gut by lipase. Suggest why. It's a bit of a naughty question, really, because obviously this section is meant to be on lipids, but it's just a bit of a recap from the summer task about enzymes. So if you think about enzymes and substrates and the specific structures that enzymes and substrates have, so the complementary structure, then that should start to make a little bit of sense with this question. So you get 1 mark for saying that the fat substitute is not complementary in shape to the enzyme's active site or enzyme lipase. You could also say that it's a different shape rather than complementary. It's not complementary, sorry. So you can say either it's got a different shape to the enzyme lipase, or it's not complementary to the enzyme lipase. The second mark that you could say, instead of this first point about the complementary shape, is that the bond between the propylene glycol and the fatty acid tail is not an ester bond, because we don't know what kind of bond it is, but they'll give you a mark for saying it's not an ester bond. The second mark is obviously that we can't fit the substrate into the active site, therefore we can't form an enzyme substrate complex. So we can't fit the substrate in the active site, therefore enzyme substrate complexes cannot be formed. So question 8. A. Some seeds contain lipids. Describe how you do the emulsion test to show that a seed contains lipids. Well, like I said before, if you look there now, this question is worth 3 marks, not just 2. So what the question's split into now, and I've done the answer in bullet points so you can actually see where you get the marks for. So 1 mark is given for what you're going to do to the sample, whereas before actually they didn't say to crush or grind the sample. Well, obviously with lipids, you sort of have to increase the surface area before you actually do the emulsion test. So it is good practice to grind the sample or crush the sample down so you increase that surface area, therefore you've got more chance of it working quicker. The second, obviously you add your ethanol, and obviously same again, they'd accept alcohol instead of ethanol. Then we add water. Now it's important, and this question wants you to say ethanol then water, and that's the way you would actually do the process, but it's quite picky. It won't give you the mark if you don't say add ethanol then add water after. If you do it the other way around, add water then ethanol, you would actually negate your mark there, so just beware. The last one, obviously, we know that if a lipid is present, we get this white emulsion formed. Now, interestingly, in the previous question about the emulsion test, it wouldn't accept cloudy. It would accept milky, but it wouldn't accept cloudy. This question, though, does actually say it will accept cloudy. So just be careful, because certain marking points or certain buzzwords go in and out of fashion. Stick to the fact, stick to it's a white precipitate or it's a white emulsion formed. And then the final point, do not accept carry out the emulsion test, because that's a given. Because it says describe how you could use the emulsion test. Actually saying do the emulsion test isn't an acceptable answer. They've said that in the question. So part B. A triglyceride is one type of lipid. The diagram shows the structure of a triglyceride molecule. Now you can see you've got fatty acid A, B, and C, and I'll just number these 1, 2, and 3. And then we've got a glycerol molecule here, and the next question says how many molecules is a triglyceride formed from? Well, this question always, for some strange reason, is quite a tricky one for people, because I think people just instantly just count their fatty acid tails as the molecule. Now remember, you've actually got 1, 2, 3, 4. You've got the glycerol as well as 3 fatty acid tails, so there are 4 molecules that make up a triglyceride. Don't say 3, because it's completely wrong. There are 3 tails, but then there's also that glycerol. So B part 2, the structure of a phospholipid molecule is different from that of a triglyceride. Describe how phospholipid is different. So this actually is the same question again as before. However, again, this time it's actually worth 2 marks rather than just being worth 1 mark. Now, with this question, you get 1 mark for saying, obviously, there is a phosphate group, so with the PO4, 3 minus or PO4, instead of the phosphate, the word phosphate. And then obviously for the second point, instead of one of the fatty acid tails. So 1 mark for phosphate group and the other in place of one of the fatty acid tails. Remember, same again, you can't say phosphorus because a phosphorus is an element and this isn't phosphorus. It includes phosphorus, but it's a phosphate group. Okay, so the next one, use the diagram, so the diagram from the previous page, to explain what is meant by an unsaturated fatty acid. It's the same question again, and it's worth 2 marks. First mark is for the unsaturated fatty acid has double carbon-to-carbon bonds. The second mark in the fatty acid tail. Straightforward, dead easy, in the fatty acid tail. It would actually accept a diagram showing that as well, so you could, if you wanted, you could draw a little mini triglyceride, mini little fatty acid tail there, and just show double carbon-to-carbon bonds. But, you know what, it's worth 2 marks, 2 minutes. That's probably going to take you too much time, and, you know, you've not got the time to waste, so literally, that's just what you need to say. So question 9a, you've got a picture of a molecule of glycerol, and then you've just got this little fatty acid with a variable R group on the end. And it just says, draw a diagram to show the structure of a triglyceride molecule. Okay, so this is a little bit of a rough diagram I've just drawn of the actual answer. So you can see that you get a mark for basically drawing the hydrogens on the glycerol as in the original diagram. Now the next bit of mark you would get is for getting the oxygen attached to the carbon. So you have to show the oxygen being bonded to the carbon, and obviously we've eliminated the OH group because obviously we've got rid of the water, and now you've got this Q group attached to the carbon on the glycerol backbone. And then the next thing you've got to watch out for is putting the R group on the other side. So don't put the R group here attached to the glycerol. It's bonded to the oxygen, because remember what we said about the oxygen is where things bond to the oxygens, like in the glycosidic bond. And before you form the glycosidic bond, the OH, the hydrogen, is bonded to the oxygen, not to the carbon. Same again here. The oxygen is bonded to the carbon, and then the R group is then attached to the other carbon on the other side. So basically, you've got to draw it looking like that, with the oxygen bonded to the glycerol, 2 oxygens because it's a Q, and then the R group on the other side. Each one needs an R group as well. And the last question, which is part B, explain why triglycerides are not considered to be polymers. Well, we know that polymers, and this is 1 mark, polymers are made of many monomers. Monomers are a repeating unit or the same unit. Now, we know that triglycerides are made of glycerol and 3 fatty acids. So therefore, that's not the same repeating unit. There's 3 repeating units because you've got three fatty acids, but it's not made of lots and lots and lots and lots of the same repeating unit. Therefore, we can't consider it to be a polymer. So this answer would be it's not made of monomers or the same repeating unit, and that would get you the 1 mark. So that's the end of the homework, and we'll start from question 10 when we do proteins. Remember, the homework's out of 17, so give yourself a mark out of 17 and put that in your homework log. Remember, be completely honest, don't watch this video whilst you are doing your homework, because that defeats the object of it. This is meant to be for after you finish your homework. And I'll see you in lesson.